Assalamu alaikum, students. Hope all of you are fine by the grace of Almighty Allah. From today, I will start a new chapter, chapter 7. The name of the chapter 7 is Properties of Matter and External Effect. And by the end of this lesson, you will know about what a material is. That means what a matter is, what we mean by property, and what the properties of solids, liquids, and gases are. Let's start with materials. Everything is made from some sort of materials. And do you know what water, air, and rocks all have in common? And they all are made of matter. Matter is something that takes up space. And now you might be wondering why they all look so different, and if they are made of the same thing. But the truth is that everything around us is made of matter, just in different shapes and forms. Materials or matters are made up of lots and lots of tiny pieces, and these tiny pieces are known as particles, and it's named as atoms. Okay, atoms are molecules. Solids, liquids, and gases are all made of lots of particles. That means atoms or molecules. Look at this diagram. This tiny ball-like structure shows you the structure of represent the molecule or the atom, which is the particles, tiny particles, smallest particle of any matter. Okay. Now, what is meant by properties? The property of a material tells us something about what it is like. A physical property is any property that can be observed using the five senses or can be measured without changing the matter. That means without changing the identity of the matter. And common physical properties include mass, volume, weight, color, size, and texture, density. Okay. And what is mass? Mass is the amount of matter in an object. Volume is how much space that matter takes up. And scientists rely on physical properties as their starting point for learning about matter and describing matter. Let's take a look at a few definitions of physical properties of matter. At first, boiling point. The definition of boiling point: the temperature at which a liquid starts to boil and turns to vapor. Okay, very important definition: the temperature at which a liquid starts to boil and turns into vapor form. Okay, and the next is melting point: the temperature at which a given solid will start to melt. Okay, the temperature at which a given solid will start to melt, like a block of ice. Okay, and then the definition of texture: the feel, appearance, or consistency of a surface or a substance is known as texture. Okay. Now the color, the property possessed by an object of producing different sensations on the eye as a result of the way the object reflects or emits light. Okay, I repeat, the property possessed by an object of producing different sensations on the eye as a result of the way the object reflects or emits light is known as color. Okay. And order, What is the definition of odor? We know about that. Odor is a distinct smell. Okay. And next is density, very important term to define different matters. Okay. And a physical property of matter that relates to both mass and volume. Okay. The physical property of matter that relates to both the mass and the volume. So how tightly packed the matter is. Okay, the amount of mass in a given space is known as density. That means the amount of mass in a given in a given space. That means in a given volume. That means amount of mass per unit volume is known as density. And so we are going to look at solids which are very dense and compared it to liquids and gases which are a lot less dense. uh, and let's get started. The arrangement of particles of matter in solids, liquids and gases. As you know, matter is anything that has weight and takes up space. Okay. And matter is anything that has weight and takes up space. A particle is the smallest possible unit of matter, and which is known as atom or molecules. And as understanding that matter is made of tiny particles too small to be seen can help us understand the behavior and properties of matter. And everything you can see and touch is made of matter. It is all the stuff in the universe. Okay, it is all the stuff in the universe. Things that are not made of matter include energy, such as heat energy, sound energy, light energy. Okay, those things are not made of matter. Okay. And they includes the energy. Okay. And energy is just we can feel. Okay. And now I am sure you are familiar with the three states of matter: solid, liquid and gas. When we look at something, our brain automatically knows, is it a solid, liquid or a gas. In this video we are going to compare these three states of matter in a more scientific way. And so we will compare them based on these four properties: shape and volume, compressibility, rigid or fluid, and do they fill their container completely. And after that we will take a deeper look into the solid, liquids and gases and compare them at a particle level. Okay, and let's start with solid. Do solids have a fixed shape? Yes, as you can see here, they have a fixed shape. This is a cuboid, and this is a cube. This is a sphere, and the watch as a irregular shape. So for solids, the shape does not change. Now, do solids have a fixed volume? Again, the answer yes, because the space that the solids occupy does not change. The volume is fixed for solids, and we can calculate that volume also. And such as if we calculate if we measure the length and the width, we can easily, and the height, we can easily measure the calculate the volume of any cube or cuboid. And if we measure the radius of any sphere or circle, then we can calculate the volume of the sphere. And also for measuring the volume of irregular shape, there is also a special process, and we will learn about in higher classes. Okay. And 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 let's look at the compressibility of solids. Usually, solids are difficult to compress. For example, if I try to press the cube, I cannot compress this cube. Okay, and are the solids rigid or fluid? And the answer is rigid, and because they have a fixed shape, and fluids are things that can flow. Okay, now do solids fill their container completely? Yeah. For example, if I try to put this ball in this container, does it fill the container completely? And the answer is no. Okay, we can easily observe from this picture. Here, the ball in this container does not fill the container completely. Okay, and the let's summarize the properties of solids. Solids stay in one place and can be held. Solids keep their shape. They do not flow like liquids, and so they are rigid. Solids always take up the same amount of space. They do not spread out like gases. Solids can be cut or shaped. And now take a look at liquids. Liquids have a fixed volume but no fixed shape. I am going to prove these 2 points to you with one single experiment here. And for the experiment, I have taken water in this beaker. And as you can see, there is 100 ml of water here. Okay, there is 100 ml of water. And now I am going to transfer this 100 ml of water from this beaker into this bottle, and then I will transfer it to the glass. And here, now let's transfer it to the measuring cylinder. And so what is the final volume here? And as you can see it's 100 ml. Okay, it's also 100 ml, and that's exactly the original volume. So what's the conclusion from our experiment? Liquids have a fixed volume and it was 100 ml all the way through. Okay, but they don't have a fixed shape. As you can saw in the experiment, the liquid takes the shape of the container. A container it is put in. Okay, and I hope you have observed the changes in volume and the shape of the liquid. Let's talk about the compressibility of liquids. If you take a plastic bottle like this containing water, if I try to crush this bottle, it looks like I can compress the water. So our liquids is compressible. But the answer is no. Okay, when I crushing it, am I really compressing the water? No, I am compressing the air inside the bottle. Okay, I am compressing the air inside the bottle. And and now if we fill this bottle completely with water like that, okay, like this figure, if we fill this bottle completely with water, I need to it's impossible to crash this bottle. So liquids are almost incompressible, just like solids. Okay, and when we fill this bottle with completely with water, and it is impossible to crash this bottle, and so we can say liquids are almost incompressible, like solid. And next, are all liquids rigid or fluid? Uh, the correct answer is fluid. Okay, liquids are fluid. The word fluid means it can flow easily, and you can, as you can see in this picture, water can flow easily, so liquids are fluids. And do liquids fill their container completely? And the answer is no. Okay, as you can see in the glass and the bottle, the water only occupies its own volume. Okay, only occupies its own volume, and the rest of the container is air. The rest of the container is air, so liquids do not fill their container completely. Let's place okay, and now let's summarize the properties of liquids. Liquids can flow because they are fluid and or be poured easily. They are not easy to hold. Okay, and liquids change their shape depending on the container they are in, and even when liquids change their shape, they always take up the same amount of space and their volume stays the same. Okay, and now we go for gases. Okay, and the third stage, now we have to look at the third state of matter. Okay, gases. Gases have neither to fixed shape and no fixed volume. Okay, just like liquids, and gases take the shape of the container that they are in, and one difference is it takes the shape of container, and the one difference is the containers need to be closed. Okay, these containers need to be closed, and now liquids have a fixed volume, but gases don't even have a fixed volume. Okay, and the volume of the gas is the volume of the container. Okay, for gases, the volume of the gas is the volume of the container. And so, for example, if I transfer this gas into a larger container, it will fill all that container completely. And or if we fill that container completely, or apply some pressure and try to fit it into a smaller container, then the volume of the gas will be the volume of the smaller container. And that brings us to the next point, which is compressibility of gas. Okay, and gases mm, mm, gases are highly compressible, and for example, I can easily squish you can see in this picture we can easily squish this balloon, or we can easily crush the air in this bottle. Okay, this bottle is filled with air. Okay, and we can easily crush the air in this bottle. That means gases are usually stored under high pressure, and since they are highly compressible, that way we can fit more of the gas in a small container. Okay, and for example, compressed natural gas is stored in a cylinders at a high pressure. Okay, and and that means our gases are highly compressible. Just like liquids, gases are also fluids, and they can flow. Okay, and for example, if I open a bottle, can you see the air flowing out? Of course, you cannot, because air is colorless. But let's say it was the colored gas, then you would easily see it flowing out of the bottle. In fact, the term fluid is collectively used for liquid and gases. And as we discussed before, gases want to fill up the container completely. For example, if these gases, if the bottle contained a gas and I transferred it to a larger container, then the gas would fill up the larger container completely. And another example is when you open a perfume bottle. Okay, perfume bottle in a room, the smell spreads to the entire room. So here the room is like a container to the perfume gas. So gases fill their container completely. Okay, and now let's summarize the properties of gases. Gases are often invisible. Okay, and gases do not keep their shape or always take up the same amount of space. They spread out and change their shape and volume to fill up whatever container they are in. Okay, like liquid gases will fill any container, but if they are not in a container, they will escape into the air. Okay, and but if they are not in a container, then they will escape into the air, and a lot of space exists between the particles in a gas. Okay, we know about that. All the matters are composed of, made up of particles, little tiny particles, and a lot of space exists between the particles in a gas, and allowing gases to be compressed, pushed together, and much more easily than solids and liquids. Gases are gases can be compressed much more easily than solids and liquids. Now let's take a look at the scientific diagram showing the arrangement of particles and compare the three states of matter at a particle level based on the 3 points and the distance between the particles and the force of attraction between the particles and the amount of movement or the kinetic energy of the particles. Okay, here you can see here is solid, very tightly packed. These circles are represents the tiny particles by which they are made up of, and in a solid very tightly packed together and no space between the particles and they are able to move very slowly. We cannot see them moving and they are moving and they vibrate, and that means we cannot observe, we cannot feel the movement or vibration of the particles in solid and but in a liquid is slightly further apart the particles, so this space for them, the between the space the distance between the particles are comparatively nearly large, and so the spaces for them to move around each other, and because they are moving they are flowing around each other. Okay, and move a little bit faster than what a solid does. Okay, liquid, and in liquid the particles move a little bit faster than what a solid does, and now on the other hand the particles are much further apart in gas. This is the uh, um, This is the diagram of arrangement of gaseous particles, and the particles, gaseous particles, are much further apart, and there is a lot of space between them, between the particles, and that's why I said earlier they can be compressed and pushed back together, and so they are moving randomly in all directions. Okay, they can move randomly in all directions, and they move very fast. Okay, and now matter can change states. Okay, matter can change states, and let's add heat and take a look at what happens right here. Okay, we have a solid. Look at this picture. We have a solid and a liquid and gas. Okay, we have a solid, and if we add heat, okay, we if we add heat to this solid, then and it goes through the process of melting. Look at this arrow, it goes through the process of melting. Okay, the process melting means the process by which any solid turns into liquid, okay, by absorbing heat. Okay, and through the process of melting, and changes to a liquid, eh, changes to a liquid if we add uh, and if we add heat to this liquid, okay, it goes through the process of boiling. Okay, it's good, this liquid goes through the process boiling, and it changes to a gas. Exactly the same happens in the opposite direction. Okay, and um, that means in the reverse process in a gas, and when we start with the gas, then as we can see over here, we are now going to cool it. Okay, we have to cool it, and through the process of condensation, now we have to apply the condensation process. Okay, through the process of condensation, the gas is going to change form back to a liquid, and if we then cool the liquid, then this liquid will go through the process of freezing and change to a solid. Let's take a look at in a little bit more detail, and hopefully you will understand this after the next few slides. Now, how does this happen? Now, how does this happen? How does the change of state happen? And look at the diagram. We have our solid here. Okay, and this is our structure of our solid, and this is liquid, and this is the gases. And if particles are in a solid, that means the particles in a solid are heated up, they gain kinetic energy, they gain kinetic energy and move slightly apart. Okay, move slightly apart, and through the process of melting, the particles change their state and become a liquid, because melting, okay, melting change their physical state and become a liquid, and because they move more slightly apart. And now if if the particles in the liquid are heated up, okay, liquids are heated up, they gain more kinetic energy and move further apart. Okay, and kinetic energy means the energy of movement, and then the particles in liquids move further apart through the process of evaporating, and they change their state and become a gas. Okay, become a gas. And now let's take a look at the reverse process. Okay, and take a look at this reverse process. And for this reverse process, how does this happen? And we start with the gas. Okay, here we start with the gas. If gas particles in a gas are cooled, they have less kinetic energy and move closer together. Okay, they lose their kinetic energy, they lose their heat energy, and then they move closer together and start to forming liquid. And this process is known as condensing. Okay, condensation. If the particles in the liquid are cooled, now if the particles in the liquid are cooled, they have less kinetic energy and move even closer together. Okay, and form solid again by freezing. Okay, by freezing process. Okay, and this is the process uh, um, for the conversion of different physical states. And now uh, um, summarize this concept. Particles are moving all the time in matters, and there are spaces between particles of matters, and particles move faster when we add heat to them. Okay, particles move faster when we add heat to them. In solids, they are closely packed, so they move slowly or vibrate. And in liquids, they are further apart, so can move faster. And in gases, the particles are very far apart, so they move quickly, very quickly. And but in solid, the particles are the atoms or molecules are vibrating, but they cannot change their position. Okay, the particles cannot change their position because the intermolecular force between them, the interparticle force, the force attraction force between the particles in solid are much stronger than liquids and gases. And now take an example, and which is water, a perfect example. This is the ice cube, and this is a bottle of glass, and this is vapor, water vapor, the three forms of water. And water can be solid, liquid, or a gas. We all of you know that. And when it is cold, it is solid ice. This is its solid state. When it is at room temperature, it is a liquid. Our liquid phase of is water. And when it is hot, it is gas, and we call it steam, water steam. Okay, and that's all for today's lesson, and that's the end of our today's class. Assalamu alaikum, students.